Hey guys, we're back down in the workshop, and today on the bench we have a Fender Performer 1000 guitar amplifier. This amp is from the early 90s. I purchased it probably about 96 or 97, way back when I was in high school. I purchased it secondhand. I was looking for a guitar amp and we were scouting around at the various pawn shops. I think I paid about $375 for it way back in the day. It saw a lot of use in the late 90s, early 2000s, and then saw very little use after I went to university. And for the last 10 years, it's basically been sitting on the in my house, not being used at all. The reason it's on the bench today is my daughter, my oldest daughter, saw the amplifier and she asked me what it was. Explained to her how it worked. She wanted to plug it in and get it up and running. So we plugged everything in, turned it on. It did power on. However, none of the pots work. The volume was basically stuck on full volume, and yeah, couldn't do anything to change that. When I did move the pots, they made an awful sound, like crackly, screechy sound. Yeah, so basically what happens with these is everything inside oxidizes. So everything from the switches to the pots, all oxidize, and yeah, they don't work, just don't work anymore. So the goal for this is to try and restore it to its previous glory, as it were. Now, this amplifier was originally marketed as a 100 watt amplifier. It's not exactly true. It's a 96 watt amplifier into a 4 ohm load and a 64 watt amplifier into an 8 ohm load. The speaker that's in the cabinet is a 12-inch 8 ohm speaker, so it's a 64 watt amplifier. Even still, it is really loud. If you're playing at home, there is plenty of volume to work with. Now, the common problem with these amplifiers and a lot of amplifiers is the pots, basically the potentiometers that control all your functions, they oxidize and start to get scratchy and stop working after a while. All the connections also get oxidized, so you get undesirable noise on into your amplifier. This one specifically, the power transistors that are in the back, the heatsink compound that they use to take the heat away from those devices was relatively poor, and so they will they create a lot of heat, and if you don't have good heatsink compound on, they have a tendency of their solder points will crack or will become weakened by that excess heat. So the goal is to switch out all these pots. I've already tried some deoxidizing solution on them. It worked a little bit. It worked better on the switches. Not so well on the pots, so we have to change all the potentiometers. I'm going to check all the solder joints on the bottom, make sure none of them have cracked, repair any that have cracked or that are making poor connections, and then remount the power transistors with better heatsink compound to try and dissipate more of the heat before any of the damage, before it causes any damage. So the first thing on the list is to replace the pots. There are 12 in total. Now, I could have gone through the diagram, figured out the value for each pot and whether it's linear or non-linear. I found a kit online, amplifierrepairparts.com, I think it was. It turns out there are 5 different pots of various values, and some of them are linear, some of them are non-linear. So I'm just going to go through my my little kit and replace each pot one at a time. I'll desolder most of the legs and then just do the final one at a time and replace them as I go. They're a little bit more expensive buying them this way, but you do save yourself the headache of trying to figure out what value and what type of pot each one is. The other nice thing is I've known and I've experienced this firsthand. This amplifier is known to have an issue with the distortion channels, in that if you have the gain setting really high, the volume setting doesn't work very well. Basically what happens is if you have the gains on the distortion channel set high and you turn the volume up to 2, it's basically at 90% volume, and then as you go from 2 to 10, you get the other 10%. Turns out this kit solves that problem by replacing, I believe it's the volume control on the distortion channels. They probably changed it from a linear pot to a non-linear one, but it's supposed to solve the volume issue with the gain channels. So bonus. So let's get started. We're going to desolder we're going to desolder all the legs on the pot and then go through one by one so things don't get too mixed up. Use a solder sucker, and if I need to, I will use some wick. Yeah, let's get this job done. Alright guys, I'm done for today. I really didn't want to make this into a two-part video, but looks like it's going to end up that way. Things don't always go as smoothly as you would like them to, even what seems like relatively straightforward projects. Yeah, throw you for a loop sometimes. So what I did was replace all the pots, as you saw. That was fairly straightforward. Cleaned out all the switches and the input jacks. Checked all the connections. Everything seems to check out fine. I even referenced the circuit diagram. Everything seems to be okay. I also cleaned the aluminum piece that the power transistors are attached to, as well as the support piece and the underlying case. Again, they were all covered with a greasy residue, so cleaned all that off. Applied a very thin layer of heatsink compound and reassembled everything. I changed out the mica support pads. Some of them most of them were broken when I removed the power transistors, so changed those out, reassembled everything. When I turned it on, it started to, it blew the main fuse, replaced the fuse, and it blew a second one. So now we're in diagnostics to see what the problem is. Now, so far what I've done, I've checked all the pots again. They are the correct pots in the correct locations. All the solder joints are fine. They're not grounding out on any of the potentiometer connections. I checked the isolation on the power transistors. They're not the problem. You basically stand them up off the board, off the aluminum back support plate. They're not having any trouble. I removed the tube, and same problem. It's still popping the fuse. So I think the next step is to borrow a Huntron tracker and do some component level diagnostics. Still not exactly sure what happened, but we will figure it out, and yeah, I'll post the solution in the next video. So until next time, I'll see you guys later.